Good afternoon, ladies and gentlemen, and welcome to the second Armand Gerbach webinar being hosted by Wright Milners. In today's webinar, we will be going through the implant design module, commonly known as M-Plant. We will also cover implant modules, tips and tricks during the webinar. This webinar is kindly being presented by Master CAD/CAM Technician E Elkhoueiry from Armand Gerbach in the Middle East Africa office. I'm Brian from Wright Milners, and along with Sheridine, we will be your co-hosts for this afternoon's webinar. First and foremost, I need to thank you, fellow professionals, dental professionals, lab technicians, dentists, who have taken the time out of your schedule to watch the webinar. I would also like to take this opportunity to thank Abdu and Ellie for kindly offering to do these webinars for our South African market. Right, before we get Ellie in front and center, I have a few housekeeping tips. Please feel free to ask any questions you may have throughout the webinar. In fact, I encourage you to ask any questions you may have for Ellie. The more questions asked, the more we all learn. To ask Ellie a question, or myself and Sheridine, simply type it into the questions or chat tab on the right of your screen. Between Sheridine, Ellie, and I'm sure we'll be able to answer your questions. There will also be a Q&A session after the webinar. Right, without further ado, let me briefly introduce you to our two CAD/CAM specialists. Firstly, Sheridine, who's from Pretoria, or rather studied in Pretoria. She's from Johannesburg area. Unfortunately, Sheridine has a bit of a microphone malfunction. We've got a bit of a gremlin in the system, but we can communicate with Sheridine via the chat section. Sheridine is a qualified dental technician, as I mentioned before, finishing her degree in 2013. Sheridine has exclusively worked on Armand Gerbach systems and has become one of the top CAD/CAM specialists, trainers, and designers in South Africa. Right, Ellie is joining us live from Beirut in Lebanon. Ellie is a certified dental technician with bachelor's degree in dental technology. This he acquired at the University of Antwerp in 1998. Ellie has well over 10 years experience as a dental technician, specializing mainly in CAD/CAM dentistry and implantology. Ellie has traveled worldwide as a product specialist, instructor, and presenter for the Armand Gerbach Middle Eastern Africa office, located in Beirut. Ladies and gentlemen, Sheridine and Ellie.
Good afternoon. Since Sheridine, she cannot talk with us because of her mic, I will start. First of all, I need to thank Milner's team to organize these webinars. It's very nice to work with them, and I hope we can make many webinars later on. About the webinar of today, it will be about implant software and implant design. It will be divided in two parts. The first part will be like presentation about implants. I'll try to make it short a little bit, and then we will go into the software to do all the steps. So I will share my screen here. Share this one. Okay. So
perfect.
So let's start. I am Eli from Armand Gerbach. It's a German-Austrian company. We work with CAD/CAM systems, and Milners are our dealer in South Africa. So to start, I will talk about the module which called Ceramill M-Plant. It's a software that will allow us to create the immersion profile, the shape of the abutment, or the final restoration through the software. So why we use this software? Why we have this question? I always ask it when we start with the implant software. Why we have the client, our client, the labs, has to buy this software and pay for it and pay to create abutments or designs when they can get their abutment for free from the dentist or from the implant companies. Most of the implant companies these days are selling implants, and they offer free abutments or half price of these abutments. The purpose from this software is, we have two purposes. The first one is aesthetic, and the second purpose is functional. So we use the implant software for two things: for aesthetic issues and for functional issues. So to create the shape of the abutment or the final restoration with the immersion profile of the restoration. So here, let's start with this picture. Most of the cases, most of the problems between dentists and labs when using implant cases will be this centrals. Because as you can see in the first picture, we have the final restoration, regardless from what we have under the gingiva. So to get this shape, the final shape and this immersion profile here, we need to have customized abutment. We cannot work with, as you can see in this picture, with cylindrical abutment. We need to have immersion profile design. We need to follow the gingiva design to get the abutment design inside the gingiva, so we can build up our final restoration or create our final restoration to get this final things. As you can see, we have here, I will do it backward. We have the design here, you can see with the X-ray. We did the design with the immersion profile. You see it in this picture here. You see the immersion profile of the abutment create the shape of the final restoration with the gingiva here. And when we designed our restoration, this will be the final shape of the crown. This is the most difficult shape, the most difficult construction that we can aesthetically, we are talking about aesthetically issues. When we have central, aesthetically, it's not easy to create this shape of abutment of crowns with the normal abutment. We need to create the immersion profile design. So here you see we have the immersion profile design with this abutment. This is one. Two, about function. What do we mean about function? As you know, implants, we placed implants. Here you see the implant in bone, and we need to cover, to protect this area from food, from bacteria. So when, if you can see, we have two pictures here. The first one, we did it with the CAD/CAM design, with immersion profile design, and you can see here, it's a zirconia design crown. So you see the shape of the crown and the quality of it. When the second one, it's a normal abutment, and the lab tried to build a porcelain on it to have the shape of the crown. If you look on the top, we had almost the same crown, even in the middle. But when we look under the gingiva, inside the gingiva, you see here, the first picture, we follow the shape of the bone with the gingiva. So we close all the gaps to avoid the food to go inside, to stuck here, and to start eat the bone, if you can see, to cover all this area from resorption, because the bacteria will kill the bone and start have resorption inside the bone. So we'll have problems with the implant later on. Maybe we'll have rejection of the implants or problems with everything, with the bone or movements, whatever. And also we can protect this area from food also. So we'll have the normal and the right shape according to this implant. One of the second picture you can see here, there is big gaps. So we have a lot of food that get inside. We have a lot of bacteria here. So we'll start having bone resorption, and you will see it with the gingiva. We'll have resorption on these areas. That's why we use the implant software. The implant software will help us to create the shape of the restoration inside the gingiva, to follow the immersion profile design, to protect the bone, to protect the implants, and also for aesthetic issues to get the final restoration. For implants in general, implant softwares, we have many types of restoration. We have restoration with titanium base. This is titanium base. We have normal titanium base. We have titanium base for screw retained restoration. We have pre-milled connections. We call it Tyform in Amangerbach. It's a cylinder from titanium with a pre-milled connection. So the system will prepare the final restoration. And also we have an add-on to our software, to the implant software. We call it InCAD-CAM software that we added to the implant software. It's made specially for Ceramill Mind, for Aman Girbach, that allow us to mill the internal connection. So we can mill the whole restoration, the whole abutment with the connection. So if we have 4 types, I will go one by one with these types of implants. For the tie connect is a titanium base, titanium connection. The titanium connection is the relation between the implant and the final restoration. This one made only for single abutments and for single restorations. It can be screw retained, but it's always for single restoration. We cannot use it for bridges. Why? Because this part will fit inside the implant and we glue the final restoration on this titanium base. So as you can see here, we have bridge made from 3 implants. I will use this technique. I'll have to make 3 single abutments, 3 separate abutments, and over this implant I will create bridge. We call it abutment plus crown. It means we will create the abutments and then we create a bridge that we cemented over these abutments. About this technique, as you can see in the picture, we have the implant in black, titanium connection, titanium base, tie 4, we call it, sorry, tie connect for single restoration on gray. We have the abutment in blue and the final restoration can be in green. Here I create picture for all these types. We have implant, titanium connection, titanium base, abutment plus crown. If you can see it here, titanium base is one part internal connection that fits inside the implant. We made over it abutment plus crown or screw retained restoration. This is from both sides. As you can see, for us, we need to create the immersion profile design. Immersion profile design. We'll create the shape of the abutment and we'll create the final restoration. This is, we call it abutment plus crown. How we start? To start this workflow, we need to prepare the model. We need to have model with separate gingiva. We can have it as intraocular scanned restoration. So during the construction, we can separate the gingiva from the model. We need to take impression for the implant to get this shape. We need analog inside the model to start working on it. Also, we need to scan, we call it scan body. Scan body related to the companies. It could be related to Aman Girbach, it could be related to any company. We can use in our system all the implant types. So you need to get this scan body from the original companies. For example, you need to start working with MegaGen. You need to ask for MegaGen library, MegaGen scan bodies, and for sure you will get the MegaGen tie connect. We need to scan these 3 parts. We scan the model alone, the gingiva alone, and then the scan body. In the software, we get 3 STL files, model file, gingiva file, and the scan body. Why we need to get a separate gingiva design? To work on the immersion profile and the shape of the gingiva inside of the abutment inside of the gingiva. Also to check the connection between abutment and implant itself. Here, designing, we start design because we are doing abutment plus crown. As you can see in green, it will be the abutment design inside the gingiva, and from the other side, from other parts, we name it abutment plus crown, so we can design the abutment and then design the crown, or we can make it as a screw retained as one part, but only for single restoration. When we finish from designing, we need to prepare the tie connect. we need to prepare the tie base, whatever you name it. In the picture, we have A, the analog, B, the tie connect. Depends, the shape of the tie connect depends from the companies. This one we call it for abutment, for single restoration with internal connection. It's one part. So we need to prepare it. We close it with wax on the top because we need to prepare the surface for cementation. We put some lubricant in the analog to protect it from the cement. Also, we close the screw channel with some wax. We need to sandblast the surface of the tie connect with 15 microns, maximum 2 bars. So we need to sandblast it. We clean it well, and then it's ready for cementation. The type of cement we use depends from the companies. Here some names. We can use Panavia, Rely X, or any other cement. Usually we use a double cure cementation, autophoto cementation, to cement the abutment with the tie connect. After preparing the surface and adding the cement, we need to place the restoration on it. So as you can see here, the zirconia restoration, we place it in position, and we need to rotate it manually left and right to find the final position, the right position. We need to fit it well in position here. That's why we use gingiva, separate gingiva, to check if your restoration fit properly in position. During construction, and in some cases, some of the labs faced problem with these restoration. It will not fit in position because they didn't follow the construction, the workflow properly. That's why when you check it in the software, you see the shape of the abutment will be like this, but when you place it in the analog, it will be rotated a little bit. That's why you need to follow the final position according to your design with the tie base. I will show you when we start designing how to follow all the steps and to make sure that you are making the right design with the abutment. Listen, when we are working with single restoration, in some cases it doesn't matter because maybe we will make it cutback crowns. We can adjust it a little bit and we can add some porcelain and it works. And even if we are making full zirconia about restoration, maybe we can adjust it a little bit. But when we work with 2 or 3 crowns, it's not easy to adjust. So that's why we need to follow the steps to get the right position and the right shape of your construction. So here, when you place it, we need to remove the gingiva to check if everything is in position. When we place it well, we need to clean and polish all this area to remove all the excess of the cementation. Okay, what we need? We need, as I said in the beginning, we need the tie base, titanium connection. From Amangerbach, we sell this product as Amangerbach. You need scan body and the screw. We screw it with a normal screwdriver. So when you want to work with the system, you need a library in the software. We need the same scan body related to the library with the same tie base from the same company. So if you want to work with Amangerbach component, you have in the software the library. You should buy the scan body and the tie connect, the tie base. When we talk about for single restoration tie connect, as you can see, it's related to the internal connection. So the scan body will fit inside the analog. That's why for each type of implant, for each diameter of implant, we have different scan body. So you have to order the exact scan body to use it with your construction, because the adaptation between the scan body will be related to the connection of the implant. So here we have scan body with a connection related to this tie base. Finish from the tie connect for single restoration. As you can see here, it's internal connection. We cannot use it for screw retained bridge. When we have more than one implant, we cannot use the normal tie connect. We should use tie connect SR, tie connect for screw retained. You can see here, it's not one part, it's two parts. We have the tie connect. One part, we place it inside the implant. We tied it inside the implant. We have caps. These caps, we glue the bridge over these caps, and then all the restoration will be screwed over the implants, will be screwed over this tie connect SR. So the tie connect SR is two parts. One part we screwed inside the implant, and then we have the cap that we glued over the bridge, and then these two parts will be fixed together with a screw. As you can see here, we have three heights for gingiva, 0.5, 1.5, and 2.5 millimeters. Depends from the gingiva height. And for the caps, we have also two heights, 3 and 4 millimeters. Depends from the restoration. In some cases, we don't have enough space. We should use 3 millimeters. When we have space, we use 4 millimeters for more retention. In the picture, you see it. I tried to make it similar to the first picture there. We have implant in black. In gray, we have the tie connect SR. You see the shape on the top. With this shape, we can make screw retained bridge with angulation more than about 30 degrees. In orange, you see the cap that we glued over the bridge, over the restoration, and then we have the final restoration. Here you see it. We have the tie connect SR. Look at the top. The shape of it will allow us to use angulation between implants up to 30 degrees. The caps will screwed with the tie connect SR, and we glue it over the bridge, over the restoration. We can make it, here I made it with implants, with abutments and crown, but usually we make it for screw retained restorations. For this type of work, we need milling machine that works with 5 axes, because we are working with different axes for the implant. We should have 5-ax milling machine. No need to have wet machine, because the wet machine, it depends from the material, not from the software itself. So here we can mill Syntron, zirconia, wax, even temp, so no need for water, but we need 5-ax milling machines. The accessories, the tie connect SR, now it's three parts: tie connect base, tie connect cup, and the small screw to screw these two parts together. We need scan body and need screwdriver. For our component, all the tie connect SR have the same head, so we need special screwdriver to place it and tighten it in position inside the implant. So this screwdriver, you should buy it with the accessories if you want to use with Amann Girrbach tie connect SR, and also need normal screwdriver for the small one. This technique, it's like easy abutments that we use it with the normal work when you want to fix screw retained denture over 4 implants. We use easy abutment. This is like the easy abutment, and here we have the caps that we glued with the denture, and then we fix it together. Concerning the scan body, the scan body here, it will be positioned over the tie connect SR. That's why we have one scan body for all implant types, because it's not related to the internal connection of the implant, but it's related to the shape of the tie connect SR. When all the tie connect SR have the same shape on the top, that's why we have one scan body for all. The tie connect SR have same shape on the top, but inside the implant, it will follow the shape of the implant. So as I said, we use the screw-retained tie connect SR technique for screw-retained bridge. We can fix the deviation up to 30 degrees between the implants. When it's more than 30 degrees, we cannot use this technique. So we need to go for angled tie connect SR, or maybe we can adjust a little bit the fit. So, but with 30 degrees, the fit will be normal and 100% fit. As you can see here, I said about the caps 3 and 4 millimeters, but you can see here we have gap between the cap and the final restoration. It's for cementation, so we have enough space for the cementation. So, the workflow, we need to prepare the model. To prepare the model the same as tie connect, we need to have model and separate gingiva, but also we have to place our tie connect SR before start scanning. Even in the mouse, if you are using intraocular scanner, you will position your tie connect SR, as you can see here, and then place your scan body. It's because we need to know the height of the gingiva. So here we have a special instrument that we use it to check the height of the gingiva. According to this, we can choose the height of our tie connect SR. As I said, we have here 0.5 height, 1.5 and 2.5, the height of the sorry, tie connect SR with the gingiva. Here we place it, and then it's ready to start scanning. We should prepare all the tie connect SR and start scan. First of all, we scan the model, we scan the gingiva, and then we need to scan the scan body. Here we place the scan body over the tie connect SR. As I said, it's one for all. Maybe you can use one and scan one by one, or you can have more than one, so you can place it and scan. As you can see here, we have to screw the scan body over the tie connect SR. I had many questions before. Do we tight the scan body like we tied the abutment, the normal one 35 Newton, or here we should tighten it 15 Newton according to the screw? The answer is no. No need to tighten the scan body in the lab when we scan, because we can scan it with the normal with your hands. So no need to tighten it 15 or 35 Newtons. It will not change when we tighten normal tight or we tighten 35 Newton. The height of the scan body will be the same. It will not fit more if we tighten more. That's why no need to tie the screw in the implant, but make sure you place it and make sure it's in position and it's not moving. That's why you should to tighten it with your hands and to be in the right position. To design in the software, we need to select the type of the scan body. I'll talk about it during the design. When we finish, we get the final restoration. We have to fix the restoration. First of all, you see the cap. We need to sandblast the cap. Even the cap here we have, you see the shape of the cap. We have it like stairs here to have more space for retention. But even though we need to sandblast the cap, we sandblast it with 50 microns 2 bars from outside. Also, we need to sandblast the restoration from inside. The same with 50 microns, 2 bars. Okay. We clean it well from the dust. We dry it. We prepare it to be ready for cementation. So after sandblasting, we should clean it well and clean the cap also. Before start the cementation, as I said, we should place the TiConnect SR. We add some lubricant all over the TiConnect SR except the tip. Then we fix the cap with the screw. We close the screw channel. We should close the screw channel with wax. So we keep only this area free for cementation. So we have to place some lubricant all over the TiConnect SR from here down to the stone. And we close the tip to avoid the cement to get inside of the restoration. Concerning the final restoration, we should close the holes with some cotton. So we close it well, and it's easy and ready for cementation. And here we start adding the cementation. As I told you, we should use autophoto double cured cementation to fix the bridge. But make sure when you want to fix these restoration, you need to finalize the bridge. You need to do all the check and the mouse, all the corrections, and after glazing, when the bridge is ready, you start cement the restoration, because we cannot place it in the furnace. After cementation, you cannot place it on the furnace. All these works will be done in the lab. It's better to make it in the lab. If you have 6-7 implants, no need to glue all the implants at the same time. So you can start 2 by 2 or 3, depends from your way to mix and to place the bridge, to avoid any rocking when you place your restoration. After that, you clean all the. When you finish, you glue the bridge. Here, you should remove all the extra cementation on it, and after that, you remove the bridge and you start polishing and repairing all the zirconia around of the TiConnect SR. So you check it, you finish it, and it's ready to send to the dentist. You will ask me, so how the dentist will do the try-in when we are not cementing the bridge? So we have to wait till the end to cement the bridge, but how the dentist will do all the try-in? So for the try-in, you can add or use a provisional cementation, not for all the implants if you want, but not the final cementation. The final cementation will be done at the end. Okay, here we're having a small comparison between our TiConnect SR and the TiConnect SR from another company. The TiConnect SR from Aman Girbach will fit inside of the implant, even if we have angled implants, because all the pressure will be on the cap from outside. When in the other companies, they make it short, like non-engage, like non-hex, so it will fit like this. There will be no relation between the TiConnect and the implant, so all the pressure will be over the screw. You will have broken screws or loosening of the screws after a while. That's why we prefer to use this type of TiConnect SR. So we tighten it well on the implant, up to 40 Newton, depends from the implants. And when we use the cap, so we screw the cap, I think 15 to 20 Newton over these caps. The workflow, as you can see, we have 2 screws, the normal screwdriver for these screws, And for the tie connect SR, as I said, we have special shape for the tip. So we need special screwdriver, you see it here, that will hold this part and fix it in position. We start. We have two implants. We should place first the tie connect SR. We'll place it in position. As I said in the lab, no need to tighten it 35 Newton. We just place it as it is. We tighten it with your hand. Then we fix the cap over it. We should sandblast the cap, as I said. Then we place lubricant here, and we close the screw channel to have only this part with relation with the cementation. After that, we place our final restoration and we glue it. In this picture, I used a wax bridge where we are trying to check if everything is working properly. I was in a lab checking this, and I used this picture. That's why I don't have enough time for make zirconia and finish the workflow and then try it. I did it in wax and just for demonstration and to show you how it works. So we talked about tie connect. We talked about tie connect SR, and now we'll talk about the tie form. The tie form is pre-milled abutments, pre-milled connection for abutments, or all what we have to do is to mill the final restoration, the final shape of the implant. These parts are made from titanium. So for Amann Girrbach machines, we need special holder to mill these abutments. We will mill it with water, as you can see. And we need special burrs because we are working with titanium. As you can see here, the tie form, the titanium block has a shape to fit inside of the holder. It's AG shape. It's not universal connection. It's Amann Girrbach connection. So you should buy it with this shape from the market. For this technique, we need 4-axis milling machine. No need for 5-axis milling machine, but we need wet milling machine because this technique, we need water to mill it. So we have, as you can see here, pre-milled connection was cylindrical titanium shape with the connection of AG connection. We need to mill and create single restoration, single abutments from titanium. It's very important to know that the connection, it will be far from the milling area. It will not be in relation with the holder, one. It will be from the other side, and the milling machine will not touch this area. That's why this pre-milled part will be 100% new and ready to fit inside the implant. As I said, we need special holder for motion 2 and for micro IC, because it's a wet milling machine. We can produce these restorations, but we need also special holder, and we need 2 special burrs for this restoration. Here, some picture about the tie connect SR. As you can see, cylinder with the shape of the final restoration. This one are not for Amann Girrbach. I place it to show you that there is in the market a lot of things that will not fit inside of our machine. If you can see here, 2 different shapes. But for us, we need to have this shape, Amann Girrbach shape, AG shape, to fit inside of the machine. The workflow, as you can see here, we have the tip of the implants. We will use the tie connect scan body because we have single restoration. Then we create our separate abutments. I prefer when if you want to work with this type of abutments, when you place it, you cut it, you fix your abutment, and then you rescan again and to make the final restoration. Don't make it on one step, abutment plus crown. Make the abutment first and then scan it, because here we need to cut the titanium and finish the surface. Like here, we cut it and finalize it. Then we will close here with wax and spray it, and then start designing as it is a normal crown for the final restoration. The component that we need to use, we have the TiConnect SR block. Scan body will be the same as the TiConnect, and we have one screwdriver. This is what we have as implants. Even now in the market, many other companies are producing TiConnect Ti4 with the shape of a G. The workflow for TiConnect SR, here we choose screw retained. For abutment plus crown, we choose abutment plus crown when we start choosing the restoration. If we need to work with Ti4, we use abutment plus crown, and when we want to choose abutment material, we choose here Ti4. The same procedure, the same steps, the same workflow, but we just choose here Ti4 instead of zirconia or wherever. To scan, we still have, I will show you how we scan. So first of all, we choose the material, the type of construction, the material for the construction, and then if we have abutment plus crown, we choose it. If we have screw retained, we choose the implant base. Also, if I have separate gingiva, we choose yes, we have separate gingiva. When we start scanning, the first step, the system will ask to scan gingiva. We have here gingiva scan. So we should, as you can see, I will show you a video. We place the model inside the scanner with the gingiva over it, without the scan body, and the system starts to scan the model with the gingiva without scan body. Here we are using our scanner MAP 600. It's an open scan, that's why I could scan and show you the video. So when we scan the gingiva, we will scan it with the model here, but I don't need to use the model, I need to cut. So we cut it and we keep it as only the gingiva. But in some scanners in the market, it could be our scanner or different scanner that can get to STL file. When we scan the gingiva and you need to move on to start construction, you see that the gingiva, it's not in the right position 100%. That's why.
Okay, we're back.
You lost me where?
Probably about 3 minutes ago.
3 minutes? So did you start seeing the videos, how we scan?
Yes, yeah, you started doing the scanning on the MAP 600. You said it was an open scanner, and then from there we got it.
So let's, sorry, I need to check. I need to show you 2 videos, and then we start with. Do you have any questions?
Nothing yet. Yeah, there's one there. Are there other lectures they're asking? Yeah, there are many other available. Just watch Abdu and Ellie's Facebook pages. You'll see a lot of links to other videos and other webinars done with Ellie. If you follow the Armand Gerbach Middle East Africa website, or Facebook page rather, there you will see they often advertise the weekly webinars with Ellie. All right.
Good?
Yep.
Okay.
When you're ready.
Yeah. So now we were here. We scanned the gingiva. Okay. And then we need to scan the lower jaw. we should add the adjacent teeth when we create the case in the database. So as you can see here, we have the model with the gingiva. We have to remove the gingiva, and then we start scanning. What we need here is the adjacent teeth. Okay, after that, we should cut the model. We will scan the scan body. For scan bodies, as I said, we have for abutment plus crown here, we need scan bodies with a flat surface that will fit inside the implant. And for screw retained, we need the TiConnect SR with a cylindrical scan body. So for this one, we will place the TiConnect SR. As you can see, we have special screwdriver that will fit inside the implant. Make sure to tighten it with your hand, and then we place the scan body with a short, small screw. With the normal screwdriver, we'll place it over the TiConnect SR. It's a cylindrical one. There is no flat surface over it. So make sure it's in place, and then we start scanning the scan body. If you don't have enough scan bodies, you can place it one by one. In this case, we have only 2 implants. Maybe you have 10 implants. No need to have 10 scan bodies, so you can start scan one by one. Now, about the abutment plus crown, or Type 4, which is single restoration, we need scan body with a flat surface to know the direction and the position of your restoration. And since the TiConnect will fit inside the implant, so we need for each type, for each diameter, scan body. Here we have 2 implants from Straumann, one 4.8, one 6.5. So we have 2 different scan bodies. So video. So we'll place the scan body. Make sure to place the flat surface buccally, and we tie the screw with a screwdriver. No need to tighten it 35, as I said, just with your hand. It's not 100% in position, but the scanner will scan it properly here. Why we place it buccally? Because if we have many implants, the scanner will not scan inside between the TiConnect scan body, between the scan bodies. So it's better to make it buccally. Now we have scan body. We can cut the model with the scan body. Make sure to keep the scan bodies connected with one part. It's better for adaptation later on, because sometimes the adaptation will lose the adaptation if we don't have parts like this. Now we'll start with the software. I will close the presentation and we will start the software. If you have any question before starting, just let me know. Or we start with the software. Now, we will do a bridge. This one, I will make 46 abutment plus crown, and 44, I will make it screw retain. I will show you all the steps between abutment plus crown and screw retain. I'm using only the implant software. I didn't choose any extra softwares like MGen or whatever. So to start, when you click on 46, first of all, you have to choose the type of construction, not the implant. It could be coping, full crown, whatever. You choose the material for this restoration, and then you choose, let me start a new job because I won't choose it like this. Okay, new job. First of all, you start adding the client name, and then the patient name, technician, and we start. We have 46. Click on it. First of all, we have to choose the type of construction. I will make it coping. I will choose the material. I will choose the material, let's say, as solid HT+. Here, we have implant base, yes. I will make it abutment plus crown. When you click on abutment plus crown, you get a new line, which is abutment material. Here, you have to choose the abutment material. It can be any material like solid HT+, zirconia, because it's separate STL file. Also, you can use it like Ty4, which is titanium abutment with pre-melt connection. I will choose this one as solid HT+. We have separate gingiva. Yes, we click yes. Defined color. 44. Also, I'll make it as coping. Here, I will use screw retained. When you choose screw retained, there is no place for abutment material because it will be one material. Gingiva separately, yes. And here we have Pontic. Also, I will choose scan gingiva separately, yes. We choose adjacent teeth because when we start scanning, we need adjacent teeth. Save and go for construction. I will not scan. I will show you how to do the design. Because I don't have the files, we need to import the files. Even if you get it from the intraocular scanner, the system will ask first for you will ask for load Joe scan. I will choose load scan. Then he will ask for scan marker. And then he will ask for gingiva. And maybe he will ask for mini files. You have to see it with these colors. Gingiva pink, scan bodies, and model. If you have with different colors, it means you did something wrong. You imported the file, vice versa. That's why you should check your files. Because you imported the file, first of all, you have to select the insertion. And here we have one scan body with a flat surface, because we use it for abutment plus crown, and this one cylindrical. In many scanners, in many times, you have here the gingiva will not be fit in position. So how to repair it, how to fix it? You close wizard. Go for additional tools. Add and remove mesh. We choose here gingiva. And now you are ready to place your gingiva. That's why I asked you to keep your gingiva with extra parts. So that's why you can later on, if you want to adapt it, you go for align mesh and you choose point that exists on the gingiva in the model. For me, I don't have points that exist here and there because I have here only the gingiva. Maybe I have point here and here and maybe here and there, but it's not enough. That's why you need to, maybe it's here and there. You see, it will not fit because I don't have space to adjust. That's why you need to have extra parts. You can move it manually, but to adapt it, you have to have extra parts from both sides. Okay. Also, you can change your gingiva design. Maybe when you got the file, it's not scanned well. You need to repair it. You need to change something with it. I need to change a little bit the immersion profile. Right-click on it. Freeform. So now you can freeform it. For example, smooth it a little bit. At the end, it's a soft tissue. It will follow your design. Okay, so don't worry if you need to change a little bit with the soft tissue. In some cases, the dentist will punch this area with tissue punch. It will be only hole to remove the healing cap. So we don't have the shape of the gingiva. He will ask you to create the gingiva shape. So you can make it this way. You can prepare your gingiva design, and then you create the healing cap and you send it for the dentist. So you can repair your gingiva and start your work. As I said, it's a soft tissue. Don't worry if you play on it from this side. Finish. We start design. Back to the wizard steps. The first step, we need to choose the library. Here we have the library list. As I told you, if you want to use any library, any component, any type base from any company, you need to have the library, the scan body physical that you will scan it, and the tie connect or tie base, whatever. So, but how we add the tie connect SR? How we add the library? You should go for C. C, program files, Ceramill software, CAD, library, and here we have implants. And you add your library in the implant library. If you are using intraoral scanner and you have to create models and you need to use inside the model the place for the analog, when you ask the company, Megagen for example, we need to use their implant library and the analog library. We should add the analog library inside of our software. So here, instead of going for implant, we go for model creator. Inside the model creator, we have folder named implants with S. Inside of it, we will add the library for analogs to use it with implant, with the model design to have holes for the analog later on. Okay, so when you add your library, you can choose it here. I need for tooth 44. It's cylindrical one. It's type 3. For Aman, we name it by types. For you, it will be anything. It could be Megagen, wherever. I will use here SR. Still, I don't have the library because I didn't choose the cap height. Here we have two heights, 3 and 4 millimeters. When I click 3, I will get the shape. Because it's a cylindrical one, you see here the red dot, you should place it in the same position. And sometimes when you scan it, the scan body, this part, it's not clear. So we can minimize the adaptation part for better adaptation. You click, you get the shape, you should click on best fit match. But you see, to check if the best fit is perfect, you click control and then you click on best fit match. It has to be green and blue. You see it? It's blue and green. It's perfect. Why here it's pink? Because it's not the same shape as here. That's why I minimize it. Next, for the second one, you forget, you click on it and you click best fit match. First of all, it takes a lot of time because it will not fit. We have two different parts. I shouldn't do it. I just want to show you if it works or not. It won't work. You see here, it's totally pink. It doesn't fit. Look, where is it? The part is totally far. That's why always when you click best fit match, click control. In this part, it's obvious. You can see the difference between both. But in many other cases, you cannot. Let's see this one. I have no idea about the scan body. Best fit match. You see it? It's blue, green, and pink. The adaptation has to be in this part. I'm not sure from this one. I choose this one. Usually you will know which library you are using, but I'm trying to show you if you forget the library, you don't have the right size of the abutment. Look here. You see it? It's green and blue, but this part, which is the part for adaptation, sorry, do it again. Usually the adaptation will be on the flat area. Okay, so the flat area has to be green and blue. And you should place the dot the right place, the right position. You see here, it's perfect. The adaptation is perfect. Look here, the blue is perfect on this area and in the flat area. Don't check the top, doesn't matter. For us, it's here. Next. So now we have the shape of the tie base. We have tie connect normal one. You see there is for retention, it's buckly. That's why if by mistake here you choose it wrong, you didn't place the red dot buckly, you place it like this here, and you click best fit match, it will not be the right position without click on control. It will adapt, but it will be totally different. You see here, when you go, you see here the retention, where is it? The retention will be in the side. It has to be in the front because I scanned this part on the front. So you will start designing according to this position. And when you want to fit it in the mouse, it will not fit because this part will be buckly. So you will not get the right direction. You will have failed case. That's why always scan your flat area buckly. Make sure to choose the red dot in the right place with control position. Click on best fit match with control. To make sure that you are working properly. You see now, the retention will be on this side, which is what we use. For cylindrical one, it doesn't matter. But if we have different heights, we will have problems. So we'll start with 44. We need to create the immersion profile design. What does it mean? We need to find the design of the immersion profile. We use it by 4 points. 1, 2, 3, 4. Wait to get the line. We can correct the line. When you click control, we can adjust the lines. Okay, like this. You can make it lower a little bit. Aesthetically, buccally, it has to be higher to clean, to see the relation between the crown. But this one is a screw retained. Doesn't matter if it's low or high. Finish. Go next. For the second one, I will skip it to show you another technique. I won't do any lines. Next. Here, if you need to, for mirroring, I don't care. We should place the teeth in position. So, the easiest way, I choose chain. I start with the first contact. I fix it. I go for the next contact. So now I have the teeth in position. Also go for simple, position your teeth, whatever. When I have abutment plus crown, it doesn't matter where is it the screw channel. I can make the screw channel like this. Because I have abutment plus crown, so screw channel will not destroy the shape of my crown. But when you have screw retained restoration, you should check where is your screw channel. For this one, it's in the right position. It's in the right position. Sometimes it's not in the right position, so you have to change the direction of your abutment. Okay? So here you have to protect. In this case, it's perfect, but sometimes the screw channel is here. So you just protect it. Finish. Next. Now, in this case, we need to create the immersion profile shape. Because this one, I didn't do it. You see here the gingiva. It's not on the level of the gingiva. We can do another thing. You just click here, some points. You click Control and you add points. Like this. Control Shift, you raise it up. And then here, you go to Advance and click Restrict All. You see, you get the shape of your gingiva according, the shape of the immersion profile according to the gingiva. You just raise it up and click Restrict All. Now I have the shape of the immersion profile. I need to stick the immersion profile to the gingiva. If you do it with sectional view, here we have, this is the design of the gingiva, and here the design of the immersion profile. I need to have it as one shape. So you can go here for bottom, use it as free form, it will be yellow. To check if it's in contact or not, to visualize it, you click on Visualize, so you can see it blue and red. When it's blue, it's not in contact. When it's red, it will be over. So you can follow here with the top angle and the bottom angle to have the shape randomly. You work with it randomly to get the shape of your abutment. If you want to work individually, you close Wizard and you click on each one and you work with it. If you want to work with both, you will do it like this. Here, you see here we have red and we have blue. To remove the red with Control and the mouse, you start. Sorry, with Shift and the mouse, and start click on it to reduce it. To add it, you click on it with the mouse, add and remove, to have the final shape, which is not easy. You see here, it's not easy to check it from all sides. I will remove the gingiva to see, and I remove the anatomic crowns. You see here you have to click, adjust, add here. you keep on playing the whole night and whole days. You will not get the shape of it. So the easiest way, randomly, it has to be bigger. You see here, it's big. Also, I will show you with sectional view. We have here, when you go for advanced, we have height and radius. The height is here, the height of the immersion profile. So we can go for 0. You see it? And the radius here, we can also go to 0 according to the design. In some implants, I cannot reduce the radius to 0. It has to be 0.2. But why we prefer to reduce it to 0 or to the minimum? Because we don't need to have more pressure on the gingiva inside the mouth. That's why when we minimize the radius, it means we will follow the shape of the implant at the bone level to avoid any pressure on the gingiva when we need to fix our abutment. In some cases, there is not enough space and the gingiva is so hard. So when the dentist needs to place the abutment in position, has to push down or to cut the gingiva, or will get more pressure on it, the patient will have more pain and in some cases will not fit properly. So we prefer to reduce the radius. So now I have it bigger than the gingiva. Okay, here you can add material if you want to get it bigger to show you. Now, close wizard. Right click, choose freeform immersion profile. Here you can add, you can remove. Also, you can play for hours, but the best and easiest and the fastest way, adaptation, you check your adaptation. If it is 0, it means 100% with the gingiva or plus or minus. Usually we make it 0 and cut immersion on scan, so the adaptation automatically will be 100% with the gingiva. For this one, the abutment is far from the gingiva, but when it is normal, it will follow the gingiva design. So for you, the easiest way, look here, check, we follow the gingiva design. You just click on expert mode, immersion profile, and you choose it. After that, with the freeform, you can, if you want, you can a little bit, just if you need, if you have some places which is not clear, finish it, perfect, okay, back to the wizard. So to create the immersion profile, the best way is to go to expert mode, right click, choose freeform immersion profile, choose adaptation, cut immersion on scan, okay, and finish. Back to the workflow. In this case, we need to make the shape of the crown, adaptation to the gingiva, shape it. For example, here when you check, you need to move it more. You see here, if you need to adjust it more. So in the step before, you go for here on this step. You see we have this one. I'll go back to show you. This is the position of the teeth. This step, go for up, adaptation, stick all. So it's not normal here. We need to make it bigger. Go for bottom. You can add points. You click on it with control, anatomic crown. See here, we add points if you want, and you can move your design to make it bigger. Okay, if you want to keep on going with the gingiva design, you see here I can go up with the gingiva. I will follow the gingiva design. So if I want to cross the gingiva, just click on it, and now you can cross the gingiva, or you can go up and down. If you want to stick with the gingiva, click like this. So you can design. You can add some points and follow the gingiva and make it bigger like this. So you can check if what you want to do according to the crown. Maybe you need it like this. So here you are changing the gingiva shape with the immersion profile. Maybe like this. In both cases, implant and crown, whatever. Maybe here also it's far, you need to move it. It's not related to the restick or stick all. Okay, so you can change the shape of your abutment, change it like this, make it bigger as you can, randomly like this, go for stick, and you stick it all. Here, go tweezer. Still here, the screw channel. As you can see here, we can change the screw channel design. What does it mean? Here we have angle. I need to change the direction of the abutment. We can, when you go for advanced, we have here click able. What does it mean? So when you click it, you can change the channel of the implant. So let's say I need to change it here. Just click on the surface. You get an angle of 30 degrees. You see, I will have abutment with 30 degrees angle. Now I change the direction of the implant, the screw channel angulation, not the abutment angulation, the screw channel. I change it here. Close wizard. Right click, freeform immersion profile, adapt, cut. Don't look, you just make it like this, very fast. Okay, back to the design and go. You see, I did straight angles, adaptation, adapt to gingiva. Freeform, I need to change the shape of the tooth. Let's say like here, I can remove my gingiva and the model. Here on this part, I can freeform it. You should follow. Always before adding, you should remove. Smooth first, and then add all the material. So like this. I am designing just to show you the abutment later on. I won't take time with the design, but just like this, little bit. You see, I did the design of the restorations. Let's say like this. I want adapt at intersection approximal 3, 4. Okay. Next. So now we did the steps. Next step. Now we start creating the shape of the abutment. Here we can change the implant, the abutment direction. So we can change the direction like this. When we have abutment with screw retained, I prefer to check with the screw channel. So when with the screw channel, it's better. You see here the screw channel, so I can follow the screw channel, which is better. Okay, without screw channel. And now when you check, you go next. You don't click on set current view, because if you check it manually and you click set current view, you see the arrow will be from this side, which is wrong. So every time you check it, you can check it manually like this, position it, and just like this. You check if it is in the middle. Now we are working with the immersion with the angulation of the abutment angulation. Okay, and you go next. We are designing the abutment now. Okay, to design the abutment, as you can see, I will remove this. So we will design the abutment because it's abutment plus crown. We will design the abutment from the top. We did the design from the bottom. To design it from the top, we have here 3 points. These 3 points related. Why? To avoid any undercut. So if I want to move the upper one to the front, this one will follow. The other side also, to avoid any undercut. But if I need to remove the top, it will remove. Then we have here angle. What does it mean? The angle between abutment and crown. For example, we have straight here angle 2. We can have angle 10, or we can have angle 0. You see here? Depends. If you have short crowns, you need angle 0 for retention. When you have anterior teeth and you have big crowns, so it's better to go for angle for retention, like cups. So for us, undo here. So we have the angle. Space. This is the space between the crown and it could be 0, you see, or it could be 4. Usually we make it the thickness of the crown, which is 1.5. Also, you can choose here auto adapt occlusion area. What does it mean? You see the arrow here, I can move it up, I can cross the crown. There is no limitation. But if you choose spacing 1.5 and auto adapt occlusion area, it will be automatically the shape of the crown, but with this 1.5, I cannot move it. But here, you see the shape of your crown will be the same as of your abutment will be the same as the crown, which is not easy to fit. That's why I don't like this shape. We prefer always to have this shape and we adjust it to have the shape of the abutment. Okay, to shape the abutment, so we will do it manually. Move this up. I can move it extra maximum like this. When we want, here, this is the abutment. If you want to mill abutment plus crown at the same step, at the same time, we should heave shoulder preparation. Like this, it will be short. Let me check with the presentation. I will show you the picture on the presentation.
Hi, folks. As you can see, we got Ellie back on. Sorry about that. All right, Ellie, floor is yours again.
Yeah, I was talking with Brian on the phone to go back. So I shared my screen. So guys, here in this case, I will show you how to use your implant software if you don't have tie-base or tie-connect, anything you name it, and you need to use the implant shape to create holes over any titanium, any abutment, any screw-retained abutment. So you choose here normal crowns without implant. So when we go for construction, we have here, we scanned 2 abutment, screw retained. I will use it as tie base. I cannot profit from the immersion profile. I just need to make a bridge and then make holes. This is not the implant software, but in some cases you have to do it like this because you don't have the proper tie base. So you have to work like this, so you do it this way. You start normal work. Double click. It's a normal work. At the end, we'll create holes for the screws. Position your teeth, just like this. Let's say like this, whatever. Let's say next, adapt to gingiva. Pull down. Just finish. Next. Next. Whatever. Cut back. Exclude. Apply. Next. Just to make it nicer. Here. Oops. Oopsie doopsie. Okay. When you finish your design, now we can profit from the software here and create, when you go for freeform restoration, next, now we can go for attachment, instead of add, we subtract. We choose cylindrical design. We place it in position. So I need to create hole. First of all, I will make the height maximum to position it over the abutment. Maybe I can choose from the top, from view, to check the position. In some cases, you might use sectional view for better positioning. Like this, I need to create hole here, so I can click rotate, move like this. Maybe I can add another cut. So I can check. This is one. You see here the screw. You see I did 2 cuts for the abutment. One cut you can see from one side and the other cut from the other side. It's easy. So now if you need to rotate, you click, you rotate, but this one is perfect in position. So it's in the middle 100%, so no need to cut more. So here also you can check. This is in the middle of your crown. Perfect. On the other side, this is in the middle of your crown. Like this. You have to apply, but before click on apply, you click on allow any changes, so you can cut through this part. Okay, apply. Same for the second one. Also make it like this, minimize the light, put your put it in position. You can check if you want like this. Make it from view. If you don't want to use the bridge, you just check it. You need the hole like this in the middle of your crown, and then you add your anatomic bridge. Sorry, not the anatomic one, the merge part. Here you just tilt it, undo, place it. It's not working because rotate, go up, move. You see, I tilt the screw now according to the view, apply, and now I have screw retained bridge. We will make screw retained bridge, which is made over normal abutments, but we create holes for the screw. Okay, this is part we can use it when we don't have the perfect tie base. Guys, sorry for the interruption. From my side, I did all the webinar. It's finished. So if you have any question, you can ask me. I can see here the guys. If you have any question, we can answer your question quickly. So Sheridan, if you have any question, or Brian. Today it was about implant. We did it simple. I did presentation why we use implant, and then we did a simple case, screw retain and the part with plus crown. I didn't use a big case because I need to get you the information simple about simple case from abutment plus crown and screw retain.
Yeah, that's good, Eli.
So,
doesn't look like there's any questions here, so looks like it was a good one. So yeah, thanks very much. Once again, Eli from us at Wright Milners, thanks so much for doing another webinar for us. I know we discussed another date in October. We will put the advert out as soon as we get that and let everyone know on the new webinar we will be doing.
Sure.
Great.
We'll make it in October, and thank you very much. Sorry for the interruption, but it happened.
Not a problem. And once again, thanks Sheridan and Eli. It's been a pleasure. We'll chat to you guys all soon.
Sure.
Cheerio. Bye-bye.
Bye-bye.